Well, it's Wednesday evening, and I'm sure the entire world is listening to us right now. Well, at least 30 people of the world, and
Wednesday?
many more coming. Isn't that Wednesday? Oh,
It's
wait, you
Wednesday.
know
No,
what?
it's
I
not
did a
Wednesday.
show this morning, and then in my mind, I think, oh, this is the second show of the week, so it must be Wednesday. Well, it's
Well,
really Monday.
it's Tuesday in Australia.
Exactly.
Oh,
Good day, mate.
So we've got a great show today. Last week, I did a show about Riedel and their logic systems. And now we're going to do a show with on EHX and its logic system. So that's fairly logical, I suppose. We got Ron Rosenblum from ClearCom and Erik Devane and John Christie from Behind the Cheddar Curtain up in Canada. And he's a long time listener to our webinars. And finally, we were able to get him on and participate in it. If you have any questions, just fill them in the questions section that's available in your GoToWebinar control panel. And they're all watching the questions eagerly. It's either that or they have to talk. So send the questions, please. Then they won't have to worry about what they're going to say. So we're going to get started, but I just want to say one little thing. Please support Practical Show Tech on our website, either as a monthly contributor or a single-time donor. And if you give us $25, we'll give you this $1.98 spray bottle of disinfectant. So this, you spray this on, and you just go, perfect.
nice.
Now I smell terrible.
ClearCom Blue.
ClearCon Blue. Okay, let me pass the show system over to John here, and we can get started here. So here's the sharing screen for you, John, and take it away.
All right, and one of the things we were talking about, we had a webinar some time ago, last month, that was dedicated to FreeSpeak 2 on the Eclipse matrix system. And we had such a great time and so many great questions, which of course we encourage that happens again, that we never really got to the very end of it, talking about how to connect the transceivers, the IPT transceivers that go with the IPA card on a matrix. So the first thing we're going to do is finish that up, and then we're going to dive into our control freak symposium here. Okay, so here we are. This is our lovely opening page, and you can see who we are and what we're doing. And there you can see who we are and what we've done and why we're here and our different levels of insanity. Okay, now, first thing we want to talk about, like I said, is for those who still remember that far back, if you still have that much RAM that you can hold on to it, we were talking about pairing a IPT transceiver into the special matrix that we have. Okay, so there's our IPT. Now this transceiver is a little bit different than the kind that comes with the base station. So those who are used to the base station system, this one's a little bit different. You see it has an SFP cage, and so we'll talk about that at some other time when we deep dive into this, but we just want to finish this one little section. So John has provided us here with a picture here. It shows you that little teeny button over there. Those of you who are familiar with the test mode that the transceivers can go in, that's the button that you push and hold as you power to put a transceiver into test mode so that you can pair a belt pack to it, so you can go and test where in your facility you want to be able to connect your transceiver before you actually connect it to the system. And the same thing holds true here. However, with these IPT transceivers, if you push and hold that button for about 13 seconds, it'll go through a series of colored LEDs, and once that LED over there just to the right of the button turns red, you can let go of the button, and what that will do is it will reset the IP address of that device, because these devices are now all IP. The IPT transceivers connect on an AES-67 network instead of the proprietary Cat5 cable back to the base station like we used in the E1 transceivers with the base station, or the EQ card in days of yore. Once that resets, now that transceiver has a new IP address, and with the magic of a cool little app, and by the way, all this is in our handouts. There's a link to this. It's called MDNS Server, and if we can, there we go. I'm sorry, MDNS Browser, which is a cool little utility that the Chrome people brought to us, but it's really hard to find. So this is the link that you can use, and again, all these are in the handouts, and it will allow you to see IP addresses of any device that you've connected on your computer that are on the same subnet, or the same subnet that you're connected to, or any of the advanced subnets that you are adjacent to when you set static IP address. Yes, Peter?
On the handouts, there are 5 handouts in there, which is the maximum you can actually put on there, but we couldn't. One of the handouts says PST 077 handouts Dropbox link to dock, and in that dock is a link to the Dropbox with another 80 megabytes of information. So that includes everything. So if you just want to take everything, get that one dock and you'll get all of it.
All right. Very good. And by the way, you will see our email addresses later on in the slides, and they're of course in the handouts that you can download. I know I'm very happy to take your emails or communicate with you if you have any other questions. This is a great forum though, so if you look down in the lower right-hand side of your screen, there's a place where you can type questions in. So if you have any questions at any time, please don't be bashful, slam them in there, and we will get to them as quickly as we can. Okay, so continuing with this, and we want to get through this. Sadly, we don't have time to relax and take our time with this, and you notice I'm speaking about at the speed of a disclaimer at the end of a car ad, because we have a lot of other stuff in the controls and GPIOs and area that we want to get to, so I want to get through this quick. Okay, so once you've reset your transceiver to a new address, you will see when you open up MDNS Browser, you will see all these devices, as you see down there, that are connected, and you see the one that says CC transceiver device. That shows the IP address of that transceiver. What you can then do is go into your browser, type in that, in this case, 172.16.10.200, and obviously this is a DHCP switch that we're connected to. Otherwise, it would be a link local address, 169.254 something something. And once you're there, you can type that into your browser and open up the CCM, the control GUI that we use for individual devices in this case. So you're interacting directly now with that transceiver. And once you're there, you can, if you want to, go to the networking tab and change that IP address to something else if you feel necessary. Keep in mind that the transceivers have 2 AES addresses that would be on the AES network. And I'm not seeing any questions coming up right now, so I'm assuming that most of the people are here for the relays and controls. So, John, I think that's correct. So unless we see anything else come up soon about FreeSpeak 2, we're gonna head over to the next thing. Do you want to quickly show what that looks like in EHX? Sure, go ahead, John.
Let me just switch down to EHX. There we go. Let's go up here. We want to go to transceivers, right? So right now I've deleted all the possible transceivers. Let's go see if we can find that one. Can you
zoom that screen in a little tiny bit?
Yeah, hang on. Give me a sec. Let me switch over to my desktop for a sec. Oops. Let me just grab something.
hit the control key and slide up with your
Hang on.
scroll wheel.
Yeah, I'm just gonna just change up my
Okay, so we
Hold
can
on 2
see now,
secs.
if you see that little green square in the bottom, there are two screens. One is available and one is attached. So we see that EHX has discovered that transceiver, and it's ready to be brought up with the up arrow. Once you tick the little tick box, you can hit the up arrow, and it will then put that into the attached transceivers. There you go, and just hit the up arrow. Yep. Want to hit that up arrow there, John?
Yep.
But you got to tick the box.
Right there. Oops, sorry, checkbox.
Yeah, that's checkbox first. Yep, there you go. And now it's going to go up there, and what we do is we apply changes.
Yeah, sorry, now I can't see the bottom half of my screen.
Yeah, you're going to have to close that screen.
Give me Alt-Tab, just switch back. Nope.
Alt
yeah,
F4.
the attendees actually can zoom in on the screen on their own. So maybe if you go back to where
okay.
all attendees, you all have
Right,
a
let me
zoom
go back.
box at the top. You can zoom in and look close on the screen.
Sorry, yeah, I screwed up my resolution doing it. Give me 2 secs. That one.
Normally, I would be playing the Jeopardy theme here, but I don't want to make John too nervous, so I won't do that.
Yeah,
right
that'd be
now.
good. The Jeopardy theme would be lovely. All right. Oh, lovely.
Are we going to have to pay a licensing fee for this? I don't want to.
Yeah, that's copyrighted. If
We
you're gonna
might.
play anything, I'm a little teapot. It's close enough. But
Yeah,
not,
I'm a little.
I'm a little teapot.
Yeah.
All right, there we go.
Yay.
There's our transceiver.
Okay, and now our transceiver has locked on, and it will go through its upload and boot process, which it takes an eternity, but it happens. Now, there's a lot of complicated stuff going on right now. It's for the locking onto PTP and DECSync and all that kind of stuff. And so we're going to take a moment to answer a question here. If I have an existing standalone FreeSpeak 2, will those transceivers work with the IPA card I'm getting with my new EHX frame? These particular transceivers are designed specifically to be run with the eIPA card. The transceivers that you have now for your base station are not designed for that. They're designed to work with what's called an EQ card. It's a different card. So sadly, Bill, that's another point of purchase for you. Apologies. But what do you get with this point of purchase? Instead of having 5 FreeSpeak 2 belt packs attaching to your transceiver, you now have 10. We've changed the codec so it uses fewer resources, and we can cram a little bit more olives into that bag. So now not only do you get 10 FreeSpeak belt packs attaching to a transceiver, but it's AES67 audio, which is a much faster, in other words, lower latency, and the audio quality is noticeably different also. The FreeSpeak 2 audio quality was always good, but now it's awesome.
And it's networkable.
And it's networkable on a AES67 network. So it's not the kind of network that you can, go to Dwayne Reed and buy a switch. You're going to have to buy something that's a little bit more big boy.
CVS. You have to go to CVS.
You have to go to CVS. Yeah, Walgreens will work. Yeah. We're kidding now. We're kidding. Okay. So this eventually, that little cog that is barely noticeable there to us old gummers who have fading eyesight, but that little cog there will eventually turn green. If we went to the monitoring screen up in the system area, we could actually look at that transceiver and be able to look at its metrics, which as soon as it's chosen, we will see on the right-hand side of the screen. Do you see the transceiver?
I don't, actually. I was just trying to find it.
Are you showing all devices there? Yeah, you are. Yeah. Yeah.
Yeah.
Let's see. Again, my I have 68-year-old eyeballs.
Here we go.
I can't see anything that tiny.
Hang on, I found it.
Oh, you kids today with the
That's the
pants and the
wrong one.
music.
Sorry, the webinar, go to webinars in the wrong spot. There we go. Gray. This one. There we go.
Okay, so now
Right.
you'll see metrics over here on the right-hand side. It'll show you, yes, it's visible to the software, and the data connection is right now not there. Either is the AES67 is not running yet. The PTP, however, is locked, and that's good. That's the first sign of things. If you, by the way, on these transceivers, that little LED just to the right, a little tiny button that we were playing with earlier, has a series of colors that will show up, and there in the manual you can see there's a little Rosetta Stone of what the colors mean when they flash, when they're solid, and as this process continues, we'll be able to see, if you're not looking at this screen that we're looking at now, but actually looking at the LEDs, you would see the colors reporting to you the status of the connection. Once it becomes
You want me to restart it?
once it becomes locked, it'll become you'll see a solid orange. So just before it locks, you see a flashing orange. Once it's locked, it's a solid orange. Okay.
All right.
Okay.
Where do we go?
All right. So since it doesn't look like there are a lot of people asking questions about FreeSpeak 2 and the IPA, IPT, I think we've achieved our goal here for archival
Right.
purposes, if nothing else. Okay. John, I think it's time for
head
us
back over here.
to vamoose. Okay.
Oops, give me a sec.
Yeah, we'll give you 2. Okay, so Peter says
I
that,
fixed that. I sent the correct link to everybody already.
okay, good. All right.
Is that, let me just see if that, there we go.
Okay, Gary, we took care of you, buddy. Peter's on the case. All right. May we have the next slide, please?
Trying to get to my presenter view.
Okay.
And
Mhm.
that one. There we go. Sorry about this. And there.
You're
Okay.
on presenter view.
Oh, sorry.
Yeah.
Let me switch
that's
that. Yes, that's.
Yeah, it's the exchange rate. Here we go.
No, that's
Almost
easy.
there.
There we go. How's that?
We don't see, we just see nice pictures of us right now. And there we go. Yes, bravo. Okay. Mr. Devane.
Okay, so.
Yes, thanks. Excellent. So what we're here to talk about is controlling the Eclipse software, controlling the Eclipse, making it do things that aren't actually in the graphical user interface, things that are beyond what most people are going to be able to access, right? That's what you want to know about. So what I've got on this slide is basically a progression of tools that are available that you can make changes to the matrix. And basically, yes, there's basically an increase in complexity as you go from the left to the right, mostly because the amount of control that you have means that you have to keep awareness of a whole new load of features. But we'll start at the left, move across to the right. Any questions at any time, just throw them down in the document and go right ahead. So why might you want to do something that isn't built into to Eclipse? Well, we're quite good at making intercom systems, but there's always going to be something that either we forgot about, we didn't put in, or most likely that we have customers that want, but the software is so big anyway that we don't want to cram in a whole load of new features that are specific to only certain people, because it makes doing the basics a lot more difficult. And we've got people who are scared of intercom as it is. We don't want to make it any more difficult to get in. So the first thing is you want to know what it is you want to do, right? And that is usually the easiest thing. You guys all know what your clients are looking for. You all know what the user's issues are, or at least what the cleanup you have to do for those issues are. So usually you have something in mind, right? I want to be able to send a call alert to have someone know something's happened. I need to be able to make sure that no one messes with my stuff. I want to be able to do a certain thing that has a timer in it, right? So the first thing to do when you have something like that is to actually go to see if there's something in EHX. So EHX is a mature program. There's an awful lot in there, and generally what happens is that people don't have an awareness of absolutely everything that's in there, right? You have jobs to do. Your job is not to be an EHX specialist. Your job is to get the show done well. So there's some simple things in there that will make life easier. So generally what you can do is the manuals are written from the point of view that you know what it is you're trying to do, and here's how to do it. So generally they're not the best to search in, they're not the best to look in, just because once you know which function you're trying to do, it will tell you everything about that function, but usually you have a human problem and not a manual problem. So one of the first things that you can do is we have a decent solutions database website accessible from the ClearCom website, where you can actually go and search. So if you were to do something like search for monitor user, for example, it would actually show you the root monitor, which is a way of using EHX to listen to the conversation between two users on a third panel. So for example, you wanted to be able to monitor what was going on, you could do that, but because it's a ClearCom function, the end users can also see that they're being monitored and mute that monitoring. So the extra levels involved, and probably I would expect that 80% of people on this webinar wouldn't be aware of that feature. Also, call management groups, the ability to have someone press a button to go to a large number of people, and the person who replies to that incoming call then gets to deal with that person the next time they talk to the group for a time minimum that you set, right? If you were trying to do that in anything other than using the GUI, that would be an awful lot of effort, but it's already built in. But again, it's not something people use that much. It's just a small checkbox in the group screen. So that's something that you may not have accessibility of. So, and another thing that's very common is to want to be able to prevent the user from being able to hit the speaker mute button because they're hitting it and missing calls or whatever it is. That's built into EHX, although you might not know where to find it, right? So there are more things built into EHX than I think the casual user would need, but I think that if you went through every single feature in EHX, it would just slow you down to a grind because there's so many ways to do any one thing. So what we've done is we have basically two different ways to make changes to the system after it's left you and it's left EHX. So you've applied the change to the matrix, and you at that point there are basically two ways of making changes. One is that at build time, so at the time that you press apply changes in EHX, what is happening behind the scenes is that your information that is currently running in memory in EHX gets combined together in certain formats to a binary format that is understandable by the rack, by the matrix code. So that takes your groups, your ports, everything, puts it together into a binary format, opens up an Ethernet connection to the frame, and sends it down. The frame recognizes that this is new information and uses that as a baseline map. It is the underlying setup that it uses for everything else. On top of that, any user action, any key that's pressed, any level that's changed, any key that's reassigned by an end user, or anything like that, that all happens basically in the memory of the frame. So you've got this core base map, and then you have things that are happening in the memory of the frame. We access those things in very different ways. Between logic diagrams and control macros, those are both things that are accessible from EHX. Those are states that are set up as you apply the map to the frame, and they can never be changed after that point. They're not live, they're not dynamic. They're simple, very simple state machines that allow certain things to happen. After that point, when things are running in memory, then we have these things called HCI and third-party keys, which allow more of an interrogation of the live system to make changes to the keys, to make changes to the system. Okay, so we would probably want to start with looking at the logic, the logic diagram, right? So the logic diagram is a graphical user interface that we've provided to make access to some of these objects that are created at build time very simple. So John, are you there?
Yep, I'm here.
Great.
Okay,
Can we take a look at the at EHX and the Logic Maestro, please?
Okay, give me a sec. Sorry, just lost my mouse. There we go. All right, switching. All right.
Okay, so we're in this, which is the logic screen. And if we go ahead and create a new piece of logic just from scratch, we can get given the option of a type, either logic diagram or control macro. The secret is that the differences between a control macro and a logic diagram are very few. What we're doing is we are creating a script in a .NET programming language underneath the covers, which is compiled at the time that you apply the matrix, the configuration to the matrix, which means that at the point where you hit apply, basically anything that we have available on the configuration is available for you to modify through logic diagrams and from from control macros. So if we open up, I'm sure that most people, if we open up a logic diagram, I'm sure that most people have had a quick look at this. So
can you see this?
We can.
Or do I need to switch the screens?
No, that's great. So just a quick overview of what we've got going on here. Again, I expect most people have had time to take a look at this. On the left-hand side, we have the objects that we're going to be manipulating. So if you look at the bottom left where it says module library, we have a control input, and that is any kind of control, which is a container that can be triggered by a large number of different things. Control output, which is a container that can trigger relays and DTMF and all sorts of things. We've got crosspoint actions, which is the ability to trigger on not only the talking from one crosspoint to another, but also when they're not talking from one crosspoint to another. So what that would be useful for would be when you have when you want to know when someone is talking, when an IFB is routing. It's basically another trigger. And then you have panel control. So if we open up panel control, and we can drop down that main menu. So where it says loudspeaker cut, if we drop that down and then do a right click, you can see we can control a lot of aspects of one or many panels. So with loudspeaker cut, loudspeaker dim, red, green, orange indication, and a relatively new arrival unlatchable talk keys. So unlatchable talk keys is a remote mic kill. It's actually taking the buttons that someone has latched on, the torque buttons that someone has latched on a panel, and unlatching them and forcing them to put them back on again. Okay. So the red spaces that are available here are places where we can plug in objects that are elements from the map that we're working on. So we've got the control labels that are all being set up, but we've also got fixed groups, directs, and panels. What's interesting here is that, especially if you're sharing your code with someone else, you don't have to put in the specific panel name into any of these red spots. You can actually just use a group and create a group. And whenever you need to, let's say you wanted to do all call or all panels or something like that, you'll be able to create a group. And then just by changing the members in the group in the regular EHX, you can then change what is happening in the control macro without ever changing the control macro. So for example, if I'm trying to apply a speaker dim to a whole load of panels, or if I want to inhibit a whole load of panels from being able to talk to a speaker that's in a position that's going to be recorded, instead of adding them manually, a bunch of panels which may get renamed or moved or whatever, I'll just have a group which is called inhibit group and have that dragged in. And whenever I make changes to that group, the changes will happen to to whatever the logic is acting upon. So John, can you show us an example of one of the things that you've got going? Is that okay?
Okay, absolutely. Let's just save that. So let's just start out with some basic logic here. Can you see all of that?
Yep.
No.
Is it too big? Too big.
Yeah. Now zoom in a little bit and we'll be good.
Okay, hang on. I'll just make it.
Just let the user zoom in.
Yeah. You can also do zoom to zoom 100%, which would also zoom to fit, which also helps.
Yeah, I'm gonna fix this. So we're gonna fit.
Zoom to fit. There you go.
But that seems too small. Is that all right?
That's fine. That's good.
Okay.
Yep.
So what we've got here, these are just all the basic logics. I took this as basically from Pete. I stole this from you. The same general concepts that Pete went through in terms of what the logic gates do. I'm going to go into simulate mode so we can see what actually happens to each of these control inputs with an appropriate control output. Under the hood, I've added some lights that actually are doing this in real time on live panels. But let's just stick to simulate. So it's just a straight through wire from a control input to a control output. You double click there, this turns on, that's turned on. Turn it off, it goes off.
On is the white line.
On is the white line, that is correct, is enabled, is live. This is a NOT gate. So at the moment, this one is off and this one is on. So we reverse it, that one. Now the output is now off and I can flip it back and forth accordingly.
Hey, John, as you go through these, maybe you can give a succinct little draw a little bit about an actual application in the real world where some of these would be helpful.
Yes. Well, the NOT gate is really very handy for just literally giving you an opposite resultant. So if you want to have something off, but it's a normally closed contact closure, you would put a NOT gate on it. So it would see that GPIO, that contact closure, as on, but you put a NOT gate attached to that control GPIO, and now the output is off until somebody breaks that contact closure. And
So
it reverses. Go ahead, Deb,
yeah,
Eric.
It'd be very common to get a GPI that needs to trigger something and the logic is reversed from what you're expecting. So for example, if you're going to be changing the IFB feed that the talent gets, it's very common that the GPI from the mixer is the opposite of the logic that you need. So you would just take the GPI, add a NOT, and then have that trigger whatever the routing that you're going to use would be. Can you do me a favor, John, and drag on a latch, and we'll talk about how that's going to work.
Okay, that's on my next page.
Okay, good.
Or let me whip through the rest of these, and then I'll jump over to the second. Okay, so the next thing we have is an AND gate. It requires something and something else, both to be the same before it gives you an output. So, for example, we click on this one, still get a negative output. We click on this one, and because both of them on, the first one and the second one, then you get a positive output. So for something that requires two, it's like you turn this nuclear key and you turn that nuclear key, and it's not until both nuclear keys are turned that the world blows up. So
one of the ways we would use an AND gate then would be if you had a setup where you wanted to flash someone's key to get their attention, and you really didn't trust that they were actually going to be responding to you. You would do something like trigger a Vox from that panel, a Vox action from that panel, and trigger the clear button for that call signal. And only if they were talking and they pressed the button would the call signal go away, and you actually believe that they were paying you any attention. That would be a use of the AND.
Okay. Now the NAND, N-A-N-D. This is basically an AND with a NOT in front of it. And actually what I've I'll show you here is that I've done both paths. There's the NAND gate. It's got a little nub in front of the round section there to indicate it's different. But this is an AND gate and a NOT gate. So that, as you can see, having only one thing does nothing. Let's just turn on the other one. Nope, that one doesn't do anything either. But both together, it does an AND gate, but then does the NOT function, and it inverts the output. So, and then if you kill either one of them, it inverts the function.
And of course, you can extend that out. So if you right-click on the NAND gate for me, you should be able to add additional inputs to that gate.
Oh, very good point.
So that you can have, it does not just two, you could have multiple inputs making the action happen. Sorry to interrupt, John.
No,
John.
that's good. I actually I knew about it, but I forgot to add that in.
Is that true of all the multiple input gates?
Most of them it is.
Like the
I can't do it to a NOT.
No, but the
AND. But definitely an AND. Add an input.
Right. Okay. Yep. Nice.
Or I can delete.
Unused.
We can delete the unused ones, and it reverts it if you add too many. Okay, so that's NAND. Let's look at an OR. So it basically is if this is on or this is on, or they're both on. So if any of them are on, it will pass through the appropriate signal.
So an example of when we would use an OR would be if we had a master control that you wanted to be able to override all the settings. You had cue lights coming on the basis of someone pressing panel buttons, and when they had the key on, you wanted the light to show up, but you also wanted it to show up if the master button was pressed. That was a way to make that logic state happen. For something a little more complicated, you might use latches so that you could have a master reset button as well that could clear all of the latches with one press.
So the NOR is again an OR with a NOT on the front of it. And so if either one of them turns on, it inverts the output. I'm gonna just jump over out to the next slide. Sorry, go ahead.
You usually use that to prove that you did electrical engineering in college, or you know how to use Wikipedia. Is generally how that goes. I tend to separate them. I tend to separate them into and not, either because I have limited intelligence or because it's easier to read when you try to find when you're trying to explain what the heck this thing is doing to someone else.
Those are the little things on the bottom. That seems too small. Is that all right? No, let's zoom in.
That's fine. That's okay. I'll
scroll
it
down.
makes sense.
Okay, so this is what Erik's was asking for. This is the latch. It's probably the most useful of them. Can create flip-flops, creates if statements. It's a great resource. Let me go into simulate mode. You can have it choose and toggle between two outputs, which are the Q and the not Q. And it just is sending a signal to it, switches its output. That is the trigger.
And John, what do you use this for in your real world application?
That I can show you shortly. I've got quite a few applications where basically it's a great way to just restore to the whatever the if I want one output, but I just want a key that is my confirmation of it coming through. I want a control key that stops the functions to it. So I'll put the control output on only one of the Q outputs, and the toggle or the trigger will actually allows me to invert it from the on position to an empty position, turning that output off. I use that quite a lot.
A very common thing to want to use the latch for would be by default, if we have a control that triggers something, triggers a relay or triggers a route, something like that. By default, if I put that onto my panel and I put that onto ROM's panel, ROM can turn it on and I can see that it is on, but I cannot turn it off without either going over to ROM's panel or being in live mode. I could refresh that key by replacing it with something else. Or in version 11 and above, I could use supervisor mode from my EHX, or in any version of EHX, I could use a B panel to supervise ROM's panel. But a more common way to do it would be to give ROM a latch disabled control that toggles the latch, give me a latch disabled control that toggles the latch, and then use the Q output of the latch to trigger the thing I wanted to trigger. I might even, if I was feeling particularly good, I might even add a panel control to flash the controls on ROM and my panel to see what was going on. And what that would do is it would allow me to toggle the latch, him to toggle the latch, which means that he could turn it on and I could turn it off, and we would both be doing to the same control. So that would be a very simple use of the latch. Another very common one would be in order to provide a master reset switch that would go to the reset input, which would just set it back to the default state, which would be off.
Okay, there are three more little elements that are really handy. The enable and the disable are great little elements that give you an always positive or an always negative. And they're really only for testing purposes only. They don't exist in the programming itself. But they're very handy if you're trying to find out, okay, is this circuit going to work for you? Because I know this is going to be an always on, this key, this GPIO, this element will always be live. Let's try it when somebody flicks a switch. And okay, you good, that AND gate works. So this OR gate this NOR gate works. The last element in the logic is the buffer. And every one of these little triangles adds 25 milliseconds of processing delay. So they're great for just simply as a timing element in several ways. One, if you have several things that you want to happen concurrently, every one of these logic elements on the left here uses up 25 milliseconds worth of processing time. So if I scroll up to this, you'll see right there, that AND gate is 25 milliseconds of processing delay. If I want something else to happen at the same time as this reacts, I can add a buffer that equals that same 25 milliseconds of processing delay so that both things happen concurrently through a sequence. Or if you just simply want to kill time, you can just simply add a whole bunch of them in sequence, and eventually your output happens. There we go.
So a good use of the timer, the delay, would be, especially in a fast-paced environment where people are really used to just hammering a key, shouting something, and then letting go. If you're trying to drive some radio equipment or something like that that has a little bit more of a delay for the relay to take or something like that, or in cases where we have public safety where you need to be able to actually have a siren get a specific trigger in order to sound. You can add either using the logic diagram or using control macros. You could add a lot of delay, which would allow the relay to stay open for a certain amount of time for a third-party piece of equipment that wasn't behaving that well to see that you actually had triggered it and not just be such a transient blip that it never actually opens up.
So just as Pete loves to tinker, oops, that's too big. Hang on, let me make this here and the right size, and then I'll fit. I was really bored last weekend, so I made that, which is just an enormous series of AND and NAND gates with lots and lots of buffers, but it also is a binary counter. So it's just, here, I'll slow this way. Oh, there's the other thing we can do is we can actually slow this whole process down so that it happens at either normal speed, divide by 10, or divide by 40. So if I just simply, you'll see things to happen fairly slowly. As they go along, you'll see these lights start to key in as the processing happens. It'll eventually go, they're actually turning on keys on a panel that are 1 through 15. or 0 through 15.
One of the nice features, I think, is the fact that you can take an output and drag it to as many inputs as you want, which is something you can do with Readle.
You can't do that with Reader? You can't add, take one?
You have a 1x2 splitter. And you have to go through the splitter. So this would be an immense number of splitters to make it happen.
Right. So,
yeah.
But
okay.
This is saving you that. There are a couple of questions coming up, by the way.
Why don't we run with some of those?
Yeah. So it says ASA, or I think it's ASA. Are the triggers and functions based on physical GPIO relays and internal actions, or can it also send network commands using HTTP, MIDI, etc.?
That's an excellent question. Okay,
yeah.
So what we've been talking about so far, remember we're moving left to right on that diagram of all the available functions. Right now, what we have is we're basically doing everything is hardware based at this point. We're triggering interfaces we have logic states going up and down. Obviously, that is very useful, but what we really want to do is interaction with other devices. So any of these outputs can be listened for. So a control firing can be listened for by an Ethernet connected device can see, but we cannot format an HTTP packet to drive an external a scoreboard or something like that. We don't have that ability. That has to be a communication protocol in between. And so for that we have HCI, a host control interface. And what that does is it gives us an API of communication, so that we can query the state of the frame, we can change levels, keys, we can reset the frame, we can change the membership of groups, we can change a whole load of things, we can do the remote mic key, for example, and that would all come under HCI.
Is that API in that pull down in the selection on the left, or?
So so what we're doing here is we're still building blocks that go down into the matrix that are just static. But what we're also talking about is the HCI protocol that we have available. So what would be a useful thing there would be that that's what Lava VSM would use to be able to control all of the panels from a soft device, or you would be able to have an Ember Plus conversion so that we could trigger things through a network. So you would need to answer the question.
Which block was that in that last drawing you?
This is not in the control macros or logic. Right now, what we're doing is we're building things that go down into the map. The HCI logic is all built into every copy of the matrix that goes out.
I thought one of those had a pull down menu to adjust the level, the latching, all that sort of stuff.
Yeah, it's basically a state machine. The things that the question is it internal, or can it go out over a network?
Oh, okay.
So the answer is we not that this is very useful. I don't think this is what the question is. We can trigger things on remote frames, right? But the world is not ClearCom. The world is a million devices that we need to be able to communicate with. And so what we would have at that point is a driver in between HCI and the outside world. One of the things we are doing right now is a HTML-based or a RESTful-based API. So you may know that the LQ, the HelixNet, the FreeSpeak 2, they all have a published API, which uses basically web technology, which uses REST API, very simple HTTP calls. We also have a converter from RESTful API to HCI in the works as well, so that you can use very standard techniques to connect. And we have I'm testing with CalRec. I'm testing an Ember to HCI converter, which is completely transparent to the user, but it allows especially Lava CalRec devices to be able to use Ember Plus to trigger things, because of course having more integration in the broadcast world between the mixing console and the intercom is only a good thing. So that is definitely happening.
Mark Kennedy is asking about a scenario, but it involves being able to monitor loss of power. How would you do that?
Obviously, Mark has watched your webinar last week, Pete.
Yes.
So
Well, let's look at one.
Yeah.
Strange. I actually developed it for you.
Funny you should mention it.
Funny you should mention that. You inspired me, Pete.
Just real
this
quick,
is exactly that.
Yeah, go ahead, Eric.
Yeah, just to answer a couple of other questions. Why is it 25 milliseconds? It is just basically a CPU no-op. It's just a logical core that we have available to us, and it's not quite 25 milliseconds, but it's close. It's basically just a processing chunk that we can allocate to doing nothing in order to have the time delay. It's obviously really super tedious to copy paste a whole load of triangles on a Logic Maestro screen. So it would be much more likely that if we were to use one of these things, we would use exactly the same setup, but we would use the scripting language to have a loop that added a large number of delays, and that would allow you to have real-time delays rather than the the 1636 that we see on the screen. You would actually use the loop, and generally you would have that as a function that is callable. So whenever Control X is fired, the Control X has a whole lot of actions tied onto it. So what happens is that when the control is fired, it will do every action it has in line. So let's say the first action is to open up a telephone line or an LQ to talk to a SIP line, and to dial up to DTMF, and you want that to be held for a certain amount of time. You could stack. There are many ways to do this, but if you were to really want to use a delay, you could just stack onto that control a whole load of delay, and it wouldn't let go of that control, so it wouldn't let go of the latch until all of those delays had been executed. But the reason why it's that
timer function in there also.
It's a delay function. It's just a delay.
So you could replace it with that if you wanted any random number of delay, a second or something like that.
Yeah. Yes.
Okay. Yep. That's all I want to know, I think.
No, but before we continue, Asa just wanted to clarify his question. He says, I'm looking to trigger the go button on QLab or recall macros and a TriCaster. Also, triggering a ClearCom action from QLab would be useful, so coming in the other direction.
I would say you need to get a contact closure on the TriCaster to trigger that go button, and use a GPO.
So I've been messing around with a few years ago. I was messing around with it because it's such a nice interface, and it does actually have the ability to execute arbitrary commands. So I have tested it, and you can send HCI commands straight from QLab on and put it on a button. That works. Obviously, there are setup that needs to happen, licensing that needs to happen, things that need to happen on the QLab side, but effectively you can put a whole load of bytes onto in QLab and have that trigger, and that does work.
But how would you have the logic create that signal?
So what I would do is I would every one of these controls that we have internally has basically an index that the system knows about. So
right.
So what we can do is from an external system, if you didn't want to trigger a very certain thing, if you wanted to change a key or press a button or something like that, that's a very specific thing. But if you wanted to make it more generic and all you wanted to do was to trigger a control from a third-party device, you can send an HCI message, which is a single message, which is that I want this particular control with this particular ID turned on.
What do you do to make that message? Is there something in this logic that creates that message?
not on what we're looking at. John, would you mind pulling up that HCI test tool?
Okay, hang on, I've got it live.
Just an external
Okay.
device, or?
It's,
So
let me
this would be basically as far as QLab are concerned, this would be basically a string that it knows how to send over and packetize and send over the Ethernet.
Right.
And so if you see, this is an older test GUI that I wrote a very long time ago. And basically, if you look in the second row where it says toggle controls, that GPSF card and GPSF pin, that is referring to either a physical relay on the device or a virtual control, which is what we've been looking at a lot of. If you were to send that message down, so John, can you go ahead and change that IP address in the top left-hand side? Can you change that to an IP address that will actually resolve to something on your system?
okay.
And this piece of software is part of HX?
This is part of the download for this part of this webinar. Yeah,
Okay.
this is
Like the transceiver? How about that?
But for the actual the CPU on the matrix.
Oh, the matrix. Okay. The LAN port 235.
Yeah.
Oops. Sorry. An extra 2, 3, 5.
Yeah. Sorry, thanks. Just hit the on button on the toggle controls. Just hit on. Right. So that message there, that's a binary message that if you were to take and plug into QLabs or a Raspberry Pi or a million different devices, if it has the ability to execute arbitrary commands across the Ethernet, that would trigger whatever control 28 pin 6 was. And I'm not expecting you to figure that out. All I'm expecting you to do is go into controls, the control screen and configuration on the EHX, and it will say card and pin available there. For times where that is dynamic, what I've done is I've also had control macros basically spit out the control numbers to a third-party device so that whenever you make a change in EHX, it's always kept in sync. I'm not saying it's the cleanest implementation, but it does work.
This puts out on a 50-pin connector or something like that, or?
No, this goes straight over the Ethernet. So if you were to take a device that was to send this over Ethernet, they would actually be able to, on your network, be able to send out this packet across the network. It would be understood by the CPU on your matrix, and it would resolve into triggering a control. Now, of course, this is a very.
I'm sorry.
Yep.
I don't want to get too deep into this, but in the package that's in the handouts are instructions how to use this, correct?
Yes, I believe so. Yes.
That's all that we need.
And of course, yeah. And Marty has said that he's looking to do a QSC command, and this would be a very similar way of doing it with the QSC devices. I believe they can do arbitrary TCP connections.
So as long as you can look up what the Ethernet command is to do something, you can use this to make that command and squirt it into the network.
Yes. So the way it works is this: is that we have a published API for everything, but we understand that again, people just want to get a job done. They don't necessarily want to be programmers. Right. So that's why we have tools like this one here, where you can literally copy paste the command, put it into a device. You don't even need to know what it is actually doing. That device will just replay that command, and the system will react appropriately.
Right.
Again, we're not hiding anything. It's a published API. You can go through, but again, we have a whole team of people to do things like this, so that you guys don't have to. Because again, there's a lot going on when you're on a job.
So what you're saying is, if you want to do this, call you.
I'm saying look at the packet we're sending. First, you can call me or any of my colleagues, but definitely you can look at the package. There are at least 20 people on this webinar who'll be able to take this tool and run with it.
Good.
Yep. Craig was asking about the open sound control, and I'm assuming that would be the same sort of interface.
OSC, yes. Yeah, that's that same sort of a web commands.
Same thing.
I haven't seen a driver for OSC. It's entirely possible. I haven't seen one, but it's entirely possible.
Yeah, I'm sure.
Now that question from Marty about dimming the dressing room, uh, need more information. How does your dressing room dim? I mean, if it's just the audio coming out of the intercom system feeding the dressing room, you can dim it using not logic, just a dim command. Or
Yeah, if the dressing
it,
room is a panel, if the dressing room is an interface or a panel, you can actually use the speaker dim function in logic to actually decrease that, to dim that cross point. But this is, Pete, this to your end, this is the panel power. I've created. So this is a demo version. In the handouts and that big zip file, your Dropbox, I've actually taken away the 2 buffer sections down at the bottom. Those are the audio alarms. One's an amber, one's a red. For external alarms and external sounds. And you just make, so there's what's called SM panel. And the SM panel is specifically, you just copy and make one of these logic programs for each panel you want to know is online. The instructions as to what you're doing are actually here in these comments. Just follow through the steps 1 through 9 as to what you need to do in EHX. And you make the appropriate changes based on, and make the appropriate controls.
That SM panel is coming out of crosspoint trigger on.
Yes. So
and being inverted into the latch.
Yes. So what happens is when right now, I'm simulating this. The SM panel is currently online.
Okay.
Somebody pulls the plug, a cleaner unplugs a power bar, off it goes.
And it's latched. Now power comes back on, it stays latched.
Yeah, so right now you get a red warning. And over here, we have our red alarm sequence going off, and the world is coming to an end. Power comes back online. It now switches these are within the stage manager, within the comms panel.
Right.
Indicators of which panel, and the red versus the orange is hey, we still have an amber situation. So we're coming back in the morning to find an amber because they plugged that plug back in when they were done vacuuming the floor.
Right.
So we want to.
It happened, but it's been restored.
Yeah, I can mute the sound. It'll take a second, but it'll mute the sound now.
And the delay is just making the flashing light?
It's just I can speed, or it's just the sound. How often does it? It's just the speed of turning on and off the sound.
Alarm, right.
Yeah, I can increase or decrease that. But right now, as far as the panel is concerned, we're still in an amber situation. But now I can restore, and it takes a couple of triggers to get us back to the point where we are now in a ready state for the next alarm. So you just flick from the comms panel. You would flick that out. Your alarm, just to retoggle it back into a ready state.
Right.
Once you've figured out what the problem is.
Okay. Can we do a more simple way of answering Mark
Absolutely.
Kennedy's request? All right. Can you? So basically, what So I'm in what Mark is asking is we want to build a scenario. Want to know if the system has a power interruption overnight. I wanted to flash a key at double time on my panel, so I know to go take a look when I get there in the morning. All right. So this is we're not using EHX. We're not in, yes, we're not in EHX. We're not in monitoring mode. We really we just want to do something simple. So basically, if I can have you, John, we'll just follow this along. Can you just go ahead and make a new Logic Maestro diagram? So by system outage, there'll be two ways of doing this, right? One would be that the frame went down for some reason, usually power related, or another would be a panel went down for some way. So those would be two separate triggers. So if I were to look for a frame going offline, what I'd want to do is I'd want to have an active GPI coming in, and whenever that GPI was disconnected, I would know that the matrix frame was gone. For a panel, there are about 15 ways of doing this. One of the ways I would do it would be to have the panel listen to a port, especially a port that has no input on it, and basically just trigger the cross point. So the way that I normally would work these would be to work backwards from what I want to have happen to how I want to trigger it. So apologies for any rational thinkers, but I'm going to do this backwards. So what I want to do is I want my endpoint to be that I want to flash a certain key or multiple keys on a panel. So I'm going to grab a panel control and put it over to the right-hand side. So my panel control has got a lot of options. I'm going to make it red so that we know something bad has happened. So we're going to go right-click and last big cut and go to red indication. And as lovely as John's flashing was, I'm really lazy, so I'm going to change my indication to a 2 Hertz flash because that's what it was asked for. So indication on turns to indication 2 Hertz. So on that panel, whichever panel I choose, it's going to flash whichever labels I choose 2 Hertz. Now at this point, I might give it to multiple positions. I might create a group and put multiple people in it. But for now, the question asks for a certain key on a certain panel. So we're going to grab a certain key and we're going to grab a certain panel and we're going to put it into the right places. So if you could do that for me, any key on any panel. So again, if I wanted the entire panel to flash, I might have a group of people and put that into the label position. But what we're going to do is, okay, so comms desk 2 has a button called SMPN, whatever that is, and then that is going to flash 2 Hertz.
PNL, yeah.
Oh yeah, so stage manager panel. Okay, great. So that is the endpoint. That is what's going to happen. If my trust level is low, I might put a control onto that and put that onto a panel. Press the button and just make sure that it's flashing the thing I'm expecting it to flash in the way I'm expecting it to flash. But given this is a webinar and I'm in control, I can just say, okay, we're going to assume this is going to work real well, and so we need to have the input. And so what we're going to do is we're going to have two different triggers for this very same thing. One is we're going to have a GPI. That GPI is coming in and triggering a control input. That control input is coming in. If that control input is coming in, they're going to grab a control input for me. On the left-hand side, control input.
Oh, sorry, control input. Yep.
Oh.
Wait a minute, that is a control input. Oh, sorry, hang on. Sorry, there we go. Sorry, I was going cross points.
So we would have the GPI trigger a control. That control would come in, but of course, what we want to have happen is we want to know if that control goes away for any reason. So what we would do is we would grab a latch, and that latch is the thing that's going to save the state, so that when we come in the morning, it's going to be the same. It's going to indicate something has happened. We'll put that on, and what we're going to do is we're going to drag from the GPI input that is coming into the matrix frame. We're going to go through a NOT, because we want to know if it isn't happening for some reason. So we go drag a NOT onto the
destination.
Drag a NOT onto the canvas.
Oh, all right, okay. I was going to do an inline. Okay. Yep.
Yeah, and then go from the control to the set.
Okay.
So if at any point.
For 2 secs here, just so you know, if you have a line, you have a stream, you can actually insert in any one of those things, any of these elements at any point. So if you create a line and then realize you need a NOT, I've just added another NOT, or you can remove it from the path. And back to you, Eric.
Okay.
Sorry.
Okay. So Q will be the output. So the output of that will go to the panel. So what will happen is if at any point that the control goes away, it's going to set that that latch, and then that's going to be flashing even if the power is restored and the GPI comes back on. So you can simulate that by turning that control on and off, and the red light is still there. So the other thing we're going to want to do is we're going to want to know if a panel it goes offline. So what we do is we set up a panel. Usually I use a party line for this. Set up a panel to listen to an audio source, and we'll have the crosspoint trigger, and that crosspoint trigger will come in, and if at any point that is not, so we can do the same thing again. If at any point that crosspoint trigger goes away, we're going to trigger a latch. So if you wouldn't mind, John, I think you know what to do at this point. Go ahead and drive that same latch.
Okay, sources are going to be the stage manager panel, and the destination output is a generic output that I've designated as panel power.
Okay.
There's our cross point.
And that goes up to set again.
Yeah, there we go.
Yep. And so either of those can figure out the issue. Now, bonus points come if you were then to add an AND gate and say, okay, if the state of that latch is on, but the crosspoint trigger is also on, then make the key flash a different color to be aware that something has happened, but it's not something you need to deal with right now. You can go have a coffee first and then figure out what the real problem is. So that is you can go ahead and use the crosspoint trigger again, come straight out of the crosspoint trigger. So if you come straight out of the crosspoint trigger, and then you come out of the queue of the latch.
This one?
Yep. And then you can then go in and basically copy paste. If you copy paste that in that panel control for me.
This one? Yep.
Control C, Control V, copy that.
Yep.
And paste
Sorry,
it,
just have
and
to
then
reach
make.
from my keyboard. It's up high.
Yep, make that. Right.
Amber?
Yeah, sounds great. Orange for the rest of the world, and then have the queue of the output of the latch trigger that the AND, and I promise you that will work. That will show you if there's been an outage, and also will show you if it comes back. It might not be a power outage. It might be that someone unplugged the panel. It might be that you lost network. It might be a million things, and that's why we have monitoring in the EHX software. But it's a good place to show that something bad has happened.
Now the crosspoint trigger on the panel, could any crosspoint on the panel?
Yeah, so usually I would use a crosspoint that is not going to have audio on it. So there's two ways you could do it, because basically you want any audio that they're going to be receiving. So if you have a situation where everyone is listening to a director, you may as well use just the director as a trigger, because you know if the director goes away, bad things are happening. If you don't have that, if you give the people more autonomy and they don't have a forced listen to anything, you could use maybe the input of an outbound only IFB, or a dummy panel, a dummy port, which is just a port that doesn't really exist on there as the trigger. Usually I would do this for multiple people using a party line, because I want to know if the user has gone away, and the system's smart enough to know that if the user goes away, then it doesn't bother routing, especially from a party line.
So this is an example of what he's talking about. This is a party line with all of those panels as talks, and then that same cross point, the panel with panel power that we used in that little bit of logic. So as long as those cross points are live between each of those panels, we have a positive, and as soon as that cross point goes away, we have an alarm.
Okay, we got some questions in here. Can outputs actually be audible noises like beeps? So we've got a very limited range of what we can do. One of the most powerful things we have is that if there's an MVX A16 card, it can be used to produce DTMF tones, which obviously can be quite useful. And every panel has the ability to have a call alert tone, which is a beep, 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 beep noise. Beyond that, if there's something else that's required, unfortunately, that's going to have to come from an external source. Yeah, that's usually how that would work. And I'm trying to read Mark's. An A2 needs to queue a particular channel on his audio private. Okay, so
Sorry, what's that?
this
Erik?
is, I'm assuming. Sorry, I'm just trying to read. So what we're trying to do is we're trying to have some routing happen selectable on a FreeSpeak 2, and so it's not stated in the question if this is going to be an Eclipse-based FreeSpeak 2 or a one rack unit FreeSpeak 2. The answer is going to be a little bit different, but we can do it with both. On a FreeSpeak 2 running from an Eclipse system, so that would be an EQ, E1, or IPT AES67. We actually just can go to the root screen on the because the party line, the belt pack is a fully fledged member of the ClickOn system. We can use it to drive anything we want. So if you just add a new root here on the root screen, you would use the belt pack, I guess, as a source, and wherever it needed to go as a destination, and you'd hang that onto a control and give yourself the ability to trigger that control, if I'm understanding that question correctly. On a FreeSpeak 2, you can also do that, but it's you wouldn't use the root screen. There's a very special logic for the GPIs available after 1.5 came out, so that you could trigger on the DB25 connection. You can trigger different things to happen. For because I know it's going to be asked, the FreeSpeak 2 also has an API that is accessible over the network, so you can add things to channels using just simple API calls straight from your web browser if necessary as well, and from QSC and QLabs and all the other things we've been talking about so far.
What do we have next?
Well, we're just looking at questions right now.
That is a great follow-up. How on earth? Right. So we have this cool little doodad that is triggered, and now you have a key that is out of action for the entirety of humanity, because you can't actually turn that off, because well pointed out, we didn't actually show a way of triggering the reset of that. So if you remember when we had it's great. I love it. When we had this very simple little system, we have actually no way to reset it. So we're hoping that, firstly, we're hoping the power outage doesn't happen, because, man, that's going to make everyone's lives easier. Let's say the power outage does happen. Let's hope by the time you get back in after break that the problem's been resolved. If it has, then the thing that's pulling the set on the latch has gone away, which means that you can use the button that we're flashing on your panel as a simple control, and that simple control will be set to latch disable, and it will go straight to the reset on that latch. So the key that you're flashing to indicate that there has been a problem. Yeah, I've got it. I understand that. I understand who that was. I know what that is. I just want to get on with it in my day. And by the way, 2 Hertz flashing is just on the edge of annoying. Just go ahead and hit the key. That will hit. You can have that control right up to the reset. Killing that reset will put the latch back into the default state. Having the latch in the default state would mean that the system's ready to go again, ready for the next disaster whenever someone decides to be stupid with your system. Okay. A flashing light on a panel a flashing light on a panel is super annoying. You know, when we're doing shows, there is too much going on, and that beeping and blooping and flashing of panels is a bad idea. So at that point, I would expect that EHX would be running. EHX has the ability to alert on certain issues, and a full power outage would be one of those issues. Yeah, for sure. SNMP is coming. SNMP.
Asa says, how about sending an email? Well, then it would be too late. I think what instead of a flashing light, you need a flash light, and a beep that's only very unobtrusive, because you need to know about that panel going offline right now. And you want it to be annoying, so you pay attention to it.
I would love to design an intercom system just for you, because it seems like life will be simpler. So yeah, everyone has
that would be the best intercom ever.
Yes, SNMP would be a decent way to get this done as well. I agree. So we have a parser that goes from event log to SNMP. It's just a little fiddly to set up right now, but that is definitely something that that should be possible. Marty, you are more than welcome. I appreciate the content, I gotta tell you. All right, sorry, I was interrupting you, John.
No, it's all good.
Okay, so are we ready to jump from? Are we ready to jump from logic diagrams to into control macros? We'll sit there for a second. Is that okay?
Sure. Do you want to just create a new one with a logic, or do we want to go into your back to the PowerPoint?
Can we take what we had? No, we were fine. Just take what we just made, the little test that we just made, that everyone just saw us make.
The system outage? Yep.
Yeah.
Okay.
The one we just made, the little one. Okay, so everyone saw that we made one on the fly, and yeah, you can trust us that it will work fairly well. So let's say that we wanted to extend that to do some other things. We wanted it to maybe function for every one of our panels. Well, it'd actually be pretty easy to change it, because that crosspoint trigger, if we were to change the source from one panel to a group of panels, if any of those panels had an outage, it would trigger the latch. So we could put a group in the position of the stage manager, and that would mean that we would have a whole load of different outages covered. But let's say that we wanted to do something a little more intense that we didn't have access to, or let's say that we thought this was such a great idea that, but we don't want to have to use the same names again. So the way this screen is working is that it is actually looking up the names of every one of these devices to figure out what it's doing, so that if you were to change the name of one of these panels, you'd actually, next time you did an apply, you'd actually get an error saying we don't know who this is. So let's say, for the sake of argument, that we actually wanted to change that, and we wanted to make it based on a port number, right? So we just want to say from port 1 to port 100, if this thing happens, then trigger. What we can do is we can actually turn this logic diagram into a control macro, and we can actually see how that works. So if you wouldn't mind, John, doing me a favor, just export out this this thing we just created, export it as a CCM file.
All right.
By the way, I'm entirely on the side of people in the comments. I would like an email. Flashing is good, but sometimes I'm paying attention to other things. But an email will probably get me. So I'm with you, Marty.
Okay. Give me a
Bill,
sec.
monitoring the redundant power supplies. There is a DB9 on the back of all of our Eclipse matrices that allows us to actually trigger based on the state of the power supplies. So you could take that straight out and use it. Quite frankly, I would be at that point looking to have a redundant EHX setup that would be monitoring this thing out and trying to do an SNMP type solution if I'm monitoring my power supplies. But there's definitely a DB9 on the frame that hardly anyone uses, which is a frame alarm for the use of finding out whether the power supply is up or not. Okay, so we have the CCM file that just got created, and so just so that we can take a look inside and see how this is actually working, if you would do me a favor and rename the CCM file to .zip.
Okay. Sorry, give me a sec. Let me go back to my File Explorer. Right, we're gonna, where are you? Number 2. There you are.
Okay. And yep, got it.
Oh. Sorry, it's giving me grief.
129 for Bill Teeter's question, by the way.
Yep.
Who's ever putting times in. While we're doing this, let me take a quick commercial announcement to say that on the ClearComm website, we have something called Solution Finder. And that Solution Finder is very, very useful. You can type in, hey, I want to connect from my ClearComm device X to some other manufacturer's device Y. What's the pinout? Or how do I create a relay to be able to trigger a talk on my panel or whatever. All kinds of really great questions and answers are there. It's a very, very broad database of questions and answers. So if you go to the ClearComm website, support drop-down menu, Solution Finder, and just type in what you're looking for, and it's very likely that you'll find what.
How you getting on, John?
Quite well. Sorry, I just had to do it in an external window. There we go. I'm switching over to that window now. There we go. This one there. There we go. And there's the GPIO
right,
as
so
a zip.
It's the same file, just renamed as a zip. So if you open that up with just your Windows Explorer or any compression utility, then we can open up the binary file, the big one.
Right. Let's see if I can open that with Notepad. Nope, it won't.
You have to extract it.
Let's extract it. Right. Okay. Yeah. Extract all. Right. And there's this super secret password,
which we're sharing with everyone.
Yes, we are. I just need to. There it is. Here, I'll just quickly.
Yep, show it on screen. Would you mind?
Yeah, I'm going to do that right now. That one. There's the super secret password. Right there. Control-C.
Yeah.
Which is also on our solutions database if you need it as well.
So it's capital C, capital L, the number 3, the number 4, capital R, underscore, small letters COM.
Oh, I need to find. Sorry, I just need to find the dialog box. See where that's gotten to. Okay, give me a second. I'm just going to go there while I switch to the.
Mike Kennedy wants to be able to set up an alarm, so not only will it go flash on a panel, but you also will find the person wherever they are. Of course, I'm wearing a ClearComm shirt right now, so what I would expect to have happen is that you'd be flashing a key on and making tones on an Agent IC device on the cell phone, but completely understand where you're coming from. You're able to unlatch a telephone, be it a Tel 14 or an LQ talking to a SIP device, and without DT map tones. So if you wanted to, you could have it dial out. Yep. You ready?
Yep. So I've entered that super secret password, and it is now extracted.
So if we you can just rename the bin to. Yep, Notepad, perfect. Notepad's great. Yep.
Hang on, switching over to this one. And that one. There we go. This is what you get. And we just delete.
So if we go to get to the using system and delete everything above it, we can see that this is a control macro that is based entirely on the latch that we set up. So I'm not expecting everyone to fully jump on board with control macros. They're available to be written in any .NET compliant MSAL language, so that's C#, Visual Basic .NET, F#. But these are actually being written at and compiled against the binary file that you're just about to download to a frame at the point at which you hit the apply button. So you have the ability to rename things, to change keys, what keys are pointing to. For example, we've had scripts that find out whether a panel contains non-ASCII keys on it, and if so, assume that they're going to be a non-English speaker for an event, and give them a certain set of keys with different names on them. Now, of course, you probably would do that with the alias function, but it's nice to know that you could actually just rewrite basically the map as you wanted to. So now that we know that the logic diagrams are written in.
So I've selected the top part. Do you want me to select the using system or ahead of it?
It doesn't matter. When you were doing it for real, you would that's perfect. Perfect.
Okay.
Okay.
There we go.
So if we just scroll down on this, this is a fully compilable Microsoft.NET C# script. If you wanted to, you could open this straight back up into Control Macro Editor or indeed Visual Studio and be able to see what was going on with it. It gives you an awful lot of power, and you can see how we do things like, can you highlight that activate LED down there? That's okay.
Sorry. Trying to, actions, activate LED. Here we go.
So an activate LED, that would be an LED that you could pass it the name of the key, or you could also pass it just the position on a panel, so that if you were changing the changing things like changing the label names, quite often you could have it do the same thing but with different label names, or you could add a for loop to loop around every one of your panels. It gives you a lot more flexibility. In order to show you what we mean by flexibility, when you do the control macros at the point at which you do an apply, you have access to absolutely everything that EHX has access to, and you have access to everything that .NET provides. So would you mind, John, pulling up the prevent download script?
Sure, not a problem. Let me get out of this. And this frame and prevent download script.
Okay, so let's just first of all let's just show people what it does when it's enabled.
Wait a minute, is that too large? It is. No. Can you see all that?
We got it. We got the whole thing.
Okay.
Okay, so all I'm showing here is that there are built-in things in EHX that you have access to, these being the map client and the enums and the actions, those actions being those things that you can do. So if you go on the right-hand side and go to click on available modules, open that up to script library. And then you can open up control actions, for example. So we have a huge number of functions that can be done. Again, these are things that are pre-compiled and send down to them. They're not live. You can't change them after the fact, but you can send them down. So this is where you would do things like call signaling, anything that isn't exposed by logic diagrams. So you can do things like talk to party lines here that you a little more tricky to do in logic in the logic diagram. So just to prove this out, could you do me a favor and just try and apply this to the frame, John?
Okay. Not a problem. Just gonna get there we go. Okay, so there we go. Let's load this into the frame. Now, it doesn't always appear on top.
Yeah.
Oh, there we go.
So for those who can read that, it says, "Are you sure you are PST?" Right. So this could be right. So this could be. This is just a very simple dialogue. This is a very simple dialog box, but it could be anything that you are available from Windows. So it could be sending an email. It could be attaching to the webcam and taking a picture and trying to work out who's applying. Obviously, with EHX, you have the ability to lock people out with passwords, etc. But it's good to know that you could take a list of names from a database live and apply those into the map as you hit apply, for example, as possible. So this one then just says, no, please stop lying. And what we have the ability to do is we have the ability to prevent the download from actually taking place. The apply doesn't take place. So the error message was someone other than Pete is trying to apply to the frame. So obviously it's a very trivial example. If you bring back up the code there, John, you'll see it's only 2 lines of code. But we use this for everything from providing an interface for things that don't already exist in EHX, to letting third-party devices know where things are in the matrix, to letting people know that the matrix has been rebooted, for example. So yeah, and that's a very, very simple example. But given that we can use the system Windows Forms namespace, you can imagine that we can use any system.net or any other communications that we want at that point. Cool. So unless you have something else, John, can we go back to the controlling Eclipse slide?
Yep. Okay. No, I close that.
Sure.
Let's go back. And give me a sec here. Is that right?
Mm-hmm.
Have you got that?
So that's great. So we've looked at the built-in functions. We've looked at the logic diagram. We've seen where the control macro comes from, and we know that we can change the map contents at the point where we apply it to the frame. HCI is a documented interface that allows you to do anything that the dynamic software or the or live mode in EHX can do. So that includes having a third-party supervise the panel, knowing when a telephone is being used in order to show a go wall, to show something interactive there, to be able to integrate with BSM, Amber Plus, QLabs, and we have functions like the ability to change every key in every position to something else, do a remote mic kill, not based on a control trigger, but based on something else. So you could do a remote mic kill if something goes through a recording state or something like that. And you can also change the page for a user, because of course you have to do that to the supervisor mode. So if you need to be able to have every panel change to a different page to show a different set of keys, for example, you could actually do that programmatically based on whatever system timer you have. In the broadcast world, there would generally be a clock that we could hook into. And then if you want to go completely crazy, then there's something called third-party keys, which I'm just going to very quickly touch on, but I'm happy to talk about at some later point. Third-party keys allows you to use, especially our vPanel interface, to control something that the system was never meant to do. And it does that by just handing off all the control for those keys via a PC interface to something else. So for example, we would use it to come up with a third screen where you could change the layout of Clang or some audio system that you have going on that doesn't speak to ClearComm directly, that isn't directly compatible, but we have taken up 2 rack units of your space right in front of you. We figure we should give you something back for it that isn't just intercom. So we'll give you the ability to change a video switcher using basic commands. And so there's an interpreter that understands what those keys are, that then translates that into, again, Ember Plus or the whatever proprietary language or whatever standard that needs to be used. So when you're doing that, you have to be very careful because you're controlling every state of specific keys on a panel, and that is a lot more work than setting up a root or a control macro. But given that you're going to be putting out a lot of panels in a lot of places, that's a useful tool. Okay. So I know that you wanted, John, you wanted to go over some of the things you've been working on.
Yeah. Let's see. Do we want to do through D? Let me then jump. Do we jump down to something like GPIO and TIFF? Would you like to see that, or do you want to just hammer through some of the basics of GPIO?
Well, we have about, if officially we have 15 minutes left, but I think we've got about 45. So, yeah.
Well, let me jump down.
Why don't you jump into where you need to jump?
Okay, just excuse all of this is in the slide deck for you guys to look at. Things like what are the pinouts for all of these GPIOs and GPIs, how we do the routes. We've basically gone through Logic Maestro, control macros. There's the test bed. These are the third-party keys. As you're saying, accessing the map data. Let's talk a bit about TIFF, Toronto International Film Festival, and their headquarters is at the Bell Lightbox here in Toronto. TIFF has started out originally, I believe it was about 10 years ago now.
What's TIFF stand for?
TIFF is Toronto International Film Festival. And the building that that is their headquarters is the Bell Lightbox, the TIFF Bell Lightbox. They started out with a Pico and 7 or 8 of the CCI 22s, connecting them to about 14 different wet party lines in each of their cinemas.
Now, just for those of you who don't know, the Pico is our 1RU 36 port analog only matrix.
So this past year, let me go back one. There we go. Yep. They and actually it came down just immediately as COVID started. They have upgraded to a new Delta Light frame. Delta Light is 4 card slots, but the Light version only has one a processor card, but can be upgraded to a second in the future at some point. They've got an IPA card and 2 analog cards for 32 ports of analog. The IPA card has 32 virtual ports, either as IVC or as AES67 connections. They have 2 panels in their main MCR, the Tech Manager panel and the Camera Switcher panel for a RoboCam. They've put an IPT, and these green lines are all AES67 connections through their switch, which is set to a boundary clock so that PTP version 2 is properly passed through the switch. And during normal operations over most of the year, they would have 1 to 2 events. These could be cinema showings, they could be just simple corporate events. And they have connections, and they'll have several users, and they'll show the films. And there'll be an administrator or a rep down with the client, and then one up in the booth who activates and shows the film. And that's free speak, and it's fairly simple. About a year and a half, 2 years ago, we added Motorola radio to it. And the Matrix has been able to do radios. And as a matter of fact, they had 2 radio interfaces since the system was originally installed. But what we couldn't do was we couldn't change the channel. Those were fixed channels on those interfaces. What we were able to do was actually give them channel steering, the ability to have the Matrix actually from the key panels, from the Tech Manager panel, actually change the channel of the radio from say security to the front of house channel or the shipping channel, depending on who they actually wanted to talk to. Now, this is their most of the year is these kinds of operations. For 2 weeks of the year, it goes a little crazy. And they have upwards of 3 to 4 different events, all concurrently, and a press conference that happens in their Galleria. And there's the red carpet teams who are all on portable radios. So we need to be able to expand this, add additional panels up in some of the cinema booths, all that interconnect with each other, connect back to the Tech Manager, talk to the people on radio, talk to the people on free speak. And all of that happens. We're even have a plan going forward where we're going to actually expand this whole system so that those same technical crews, the tech support teams from the Lightbox can actually go to various external cinemas around the city, Princess of Wales, Roy Thompson Hall, Scotiabank, the Ryerson Theatre, where they have standard party line. We drop in something like an LQ R2W4 that can talk to the ClearCom for their booth ops there, can talk to the radios on site, and the tech support team could actually use Agent IC to and connect with them and even talk to them on route while they're going there. And the core to all that radio channel steering I was talking about is this series of it's Phoenix Contacts clip line DIN rail terminals. It's a terminal strip, kind of a fancy one, but it allows you to understand how it all goes together. So in our original design, we had 2 radios that would have channel steering to them. We're going to take 8 of the relay outputs from the matrix frame. We're going to have the 2 standard FOR22 representing the audio that goes to each of those radio, and the ability to engage the wiper, the push to talk function of the radio. Those come from the FOR22 in the bottom 2 DB9s. But these 8 relays here, which are actually 2 groups of 4, so 1 through 4 and 5 through 8, are designated as the channel steering in each of these mobile radios. Let me just quickly switch over, and I'll show you what this looks like in EHX quickly. There we go. So over here in the Lightbox, so obviously I'm not online with the Lightbox itself. but as we said, lots and lots. We have, here's the two audio input channels for the radio. If we go down here to GPOs, we are actually interested in these ones down here. Radio 1, CS1, 2, 3, 4. Radio 2, CS1, 2, 3, 4. And we have an additional 4 built in for future use. When we add a Relay 6 module for a third steerable radio. And how these all come together is I'm going to go to controls and let you. So we have quite a lot of controls on this one, but let's go look at right here. So what we're looking at right here, oops, I think I can, oops, no, that's not the one. That's the one I want to get rid of. So radio 1, channel 2, radio 1, channel 3, 4, and so on. So if I click on security, which is channel 1, I'm going to bring this back up. What you're going to see, to get to channel 1, we have to engage matrix GPIO number 1. Well, that's fairly simple. Channel 2 goes to CS2. Now, channel 3 actually uses 1 and 2. So what we're looking at here is a series of binary codes that represent ons and offs, and there's actually binary digits. And I'm going to switch. I think, and what you actually have, if you, in the handouts, I've actually given you what that binary code is, what it takes to actually build this for a Motorola radio, and which ons and offs you need. Let's go up a little higher when it gets a little more complicated. As you see, this one's 2, 3, 4. This one's 3 and 4. 1, 2, and 4. And what we're doing is we're just simply closing those contact closures that we let me just go back one. Oops, there we go. So what we're doing is just closing the relays 1, 2, 3, and 4 for the first radio, and they are going to pins 17, 19, 20, 21, 22, and 24 on this Motorola 26 pin right here on these. And if we close the certain ones in a certain order, it knows that it needs to change the channel of the radio. And okay, so that's the GPIO section to go an example of. If I've got time, I'm just gonna move on to the Shaw, where we played around with some cool, handy little logic. Basically, at the Shaw Festival, in their main festival theater, we installed a Delta frame with a fairly small number of panels, but 8 free speaks, quite a lot of antennas, and there are a few more yet to go in to expand into some other parts of the building. But they also use a lot of original Encore party line belt packs. And those are all powered using the LQ boxes you see down at the bottom. And those can be thrown down for things like the rehearsal. So the ones you see there for LD video, ALD, and follow spots, the sound design and sound assistant, those are temporary LQ boxes that get put on the rehearsal desks out in the house. When those people go back to their normal operational locations, those go away and go back into the back room, and the system goes into show mode where they connect them all. Let me just jump back over here. There we go. So what I wanted to show you for the Shaw Festival, let's go look at this frame, is down in Logic. So one of the things we did with them is that some of their stage managers, once they actually sunk their teeth into operating on their panel, they discovered that their stage announce, which they use for talking to the actors during and technicians during rehearsals, and then talking to the house during performance, was interrupting and turning off their panel keys. So they asked that we create a little algorithm that would allow them to initiate it. And so what I did here was basically created a little bit of logic and moved the talk key, the panel mute, onto the first key of the panel. I'm just gonna jump out of this, show you the panel. Oops, no, I don't want to save that. Let's go to the panel and stage manager panel. There we go. Let me zoom in a little closer to just the keys. So it originally started up in the top left corner, but in later years, it's now up in the top right corner. And it is this mic on off switch, and it turns on and off, zooming out 2 seconds, and it turns on and off the actual mic of the panel that would normally be over here. Oh, that's menu, shift, mic enable, there it is, that one there. So that one light turns on and off. And if you hit, in this case, the voice of God is down the bottom, is an IFB. And that would disable temporarily the panel mic. So the stage manager asked that we have a nice big, easy to use button, and it was not disabled by the use of the voice of God. So I used that a little control into the logic that controlled what happened with the stage manager's audio going to these various party lines when the IFB was turned on and off. So that's that. Are there any questions? Or would you like to go from there?
Not yet. Okay.
I think we've pretty much done all the questions. None have come up on this last section.
Mm-hmm.
Anything else you want to cover?
Well, one thing I just want Erik to mention is in the Erik's cool projects area in the handouts, he's got a utility that allows us to actually print out into an Excel file what you have in your matrix, and it's actually
nice.
it's an interesting little utility. And one other question, I'll throw this out to Pete and Eric and John. How do you manage questions when somebody comes up and asks you for something? Obviously we always want to help everybody, and we want to, make sure that everybody gets what they want. But there's a certain sort of a managerial style that we all have, and I'm curious who does what to whom and how. Somebody comes up and they want to, hey, I want to be able to push a button and have it call my cell or something along those lines.
My first thought is how can I do it? How can I do what they want me to do? But it's overridden depending on when they ask me. If we've already done our dress rehearsal and next thing is our show, I am very reluctant to do anything other than maybe moving a key on a panel. I don't want to do any major programming. But when somebody calls up and, that's the nice thing about all of these digital intercom systems. They are so flexible. You can do, it's a challenge. Somebody says, I want this to wash my teeth and dry my hair. Well, I can figure out how to do that. Give me a couple of minutes.
We can even tone your hair in a specific color.
Hey, this is 0001. Wait till I get to 111.
Okay. Yeah. Hey, at least you've got some up there.
There we go.
Yeah, 30 seconds to air is not the time to ask for, by the way, I need. Yeah.
No, my one caveat to Pete's is that my caveat to that is it the client that's asking? Is it the end? Is it actually the person paying the bill who signs the check?
I would still say no.
Yeah. I mean,
Once you're close to air and you've got a humming system and everything's working, all of us have been around long enough to know that's not the time to make any kind of at least a major change like that.
I'm sure that anybody on the crew, from stage manager to director, would back you up on that statement.
Sure.
Yeah. At that point, I would have to take it to the TD, or somebody up above me would have to say, yes, you need to do this now. This is important enough to, and somebody else will take responsibility.
Yeah.
For it. Does that answer your question, Ram? Or?
Yeah, it does. That answers my question. Absolutely. Yeah. Eric, you want to talk a little bit about your fun little utility for printing out the ports and such?
Oh, for sure. Absolutely. So, John, can I lean on you again?
Sure. Where do you want me to go?
To page 23, accessing map data on your slide.
Let me go back.
So again, you can spend your entire lifetime doing really cool things with intercom and never know how things are working underneath. But if you are interested, there is actually an object model that has every port, every group, every pilot line in it, and it can be changed using software. So one of the things that we can do is to use the shared DLL, which is something we can use with other programming languages, and we can actually change things on the fly. So what I've done in the past is, for example, change the system numbers of something from one map to another, or changed every instance of something to point to a different system. So what I'm looking for is two pages after that, one page after that, which is the so on the left-hand side there, it's what you get in any .NET programming editor environment that you can use. Actually shows you what you can get out of those HXN files. So the HXN file is just a serialized view of what everything that makes up a configuration. And so if you can look down there, that we have access to all the cards as a list of cards, and all the antennas as a list of antennas. So you can actually manipulate those using standard programming techniques. Again, not expecting you to have to, but it's interesting to know that it's there, especially if you need to be able to document what you've got going. So one of the things we have an example of, I'm sure that Ram included this, and if we have any problems, just get in touch with us, we have the ability to read through a HSN file and output the results in an Excel format. So it's a real simple thing that we use. And so so if I can present for a second, do that. Anyway.
Peter, does Erik have presenter creds here?
Yeah. So the output will look something like this. So this is an Excel spreadsheet from one of the customers that I just had handy configuration. It gives you a list of all of the cards that they have on their system. Seems like a pretty vanilla system right now with a bunch of analog cards, and gives you the ability to see which groups they have and who are in the groups. They have no party lines. They have not many GPIs, but this will give you the ability to actually see what is going on any on the system, and if you need to back up to for documentation purposes, this is a useful way to do it. Is that what you were thinking, Ron?
Yep, awesome.
Very useful.
Very useful, absolutely, yes.
And you told, I mean, no program from any manufacturer has a useful way of printing out what the system is, other than doing screenshots, which is pretty much what I do all the time.
Yeah. So I've been working on this. I've also been working on a Dante exporter. If you Pete, if you want to talk to me at some other point, which can just output all of your Dante devices and all of the associations with them, because that can get pretty big too.
That's good.
Yep.
Yeah, with the screenshot you can't copy and paste. With this, obviously you can use it for all kinds of fun tools.
Now, I'm sure your next step is to take that same file and make it import.
Yeah, that would be the plan. There are a lot of projects going on, but who doesn't want a round trippable system? For
exactly,
sure.
Exactly. Because one little feature I use in Riedel a lot is you can export the entire port list, edit it, and as long as you don't change the order of what you're importing, you can change all of the long names and the short names after you've edited them in Excel, which is useful if you want to do mass changes in names and stuff like that.
Yeah, one of the things we really need to do a better job of is we have all these little apps that we need to put on the web. So, for example, reordering of screens, of pages on a V panel, changing the names of every panel out, changing all of the key types to something else. These all exist as small apps that the AE team for ClickCom uses all the time, and we're quite happy to share it. It's just that we need to make that web accessible, so that anyone can firstly know it's there, and then also use it. So I'm certainly happy to spear that effort.
I'm sure the issue is if you put a list out there, then you have to maintain it.
Yeah, it's one of the really nice things that we have now is that every version of EHX comes with a DLL that is compatible with every old version of EHX.
Right.
That was always the problem. That compatibility between versions was always a problem. Now we are really good at the latest version is able to open up everything from the parts. So that has gone away a little bit, but absolutely. I think there's a couple of reasons I like working for ClickCom. One is that if you ask me a question, I don't ask you for a serial number. I just want to know what words that you're getting. The other thing is that we really obviously we're not doing a great job of sharing everything we have, but We are publishing our APIs for HCI. We're publishing our APIs for HelixNet and LQ. If you can do stuff with them without, great. But if you need a little help, well, that's what we're here for. But I feel like that's what's going to push us forward, because a control macro is real nice, but it does stay within the ClearComm world. And the number of times we want to be able to pull in a list of names from an AS67 stream or Dante stream, or be able to communicate with a recording system or whatever it is. Those are coming up daily, and that's exciting.
Well, I know in my experience, and I'm sure in John's, you get an issue with something in a ClearComm or in intercom, particularly calling you, it's the first person I think of, So if I have a serious issue, be it repair or programming.
Yeah, I've got Erik on speed dial.
There you go. There you go. Perfect. Anyway, this is been a great show, and I really appreciate it. There were times when I was thinking, what are they talking about? Because a lot of it is like right over my head, and that's over my head. So I have to spend some time and sit down with it and figure it out. But obviously, I'm going to look in that handouts section and spend a little time figuring that out, because it's a different way of thinking than other intercom systems. So
yeah, we're a little bit more port centric than button centric, and like you say, it's just a different way to skin the cat. I personally want to thank Erik and John, and also everybody who asked questions. They were great questions, and thanks for the accolades. You see our email addresses here. You can always email me, and when I don't know the answer to the question, I'll send you to Erik. No, but seriously, also, yes, there are a lot of things here. You're all drinking from a fire hose. Mm-hmm. The great news is, if you go to www.practicalshow.tech, this show within 24 hours will be archived, and you can go back and you can review the show, or you can look at the handouts. Like
all the handouts will be posted with the show to download. Mm-hmm. Right.
Asa, on one of the
we have another question.
Yeah, go ahead.
So
go ahead.
We can take in AS67 audio either through the Dante card, which works in a fairly decent way on a local network. Doesn't play nicely with big networks. But we also have the IPA card. So version 12 is imminent, and version 12 is being run by a large number of places now. That allows the IPA card to be used to take in and give out AS67 streams, and that works really well. So the really nice thing about the IPA card would be that you could mix and match panels and mobile clients and AS67 streams, and talk to an existing Dante network if you have it, or talk to an AS67 network. It's a very versatile card.
And Maddie too, and there are lots of different things you can do. Hopefully one day we'll be able to do an EHX light, talking about the more pedestrian things that we can do in EHX for the people who are just getting their fingers wet.
I'm sure there's a group of people who just want to know how to make 8 party lines, put on 8 channels, and that's it.
Sure, absolutely, and we'd love the opportunity to do that, Peter, anytime.
Yeah. Cool. Well, we're going to have a couple of really exciting shows in the next couple of days. On Wednesday, Solid State Logic is going to be with us. Steve Zaretsky is going to be here from Solid State Logic. But Michael Abbott, an incredibly good friend of mine and a master engineer, Kenny Kaiser and Matt Kerr, who all are experts on Solid State Logic devices, are going to be here to deep dive into what these fabulous consoles can do. And then on Friday, Electrosonics is going to talk about their digital wireless. Carl Winkler is going to be back and talk digital, and we'll be nothing but zeros and ones by the weekend. Well, thank you very much. I want you to all remember, keep calm. Keep calm.
I get it.
Exactly.
I totally just saw that.
Where'd you get that, Pete?
I made it.
Okay. Are they for sale on the PST website?
No, that's a good idea. I should make
You should.
a bunch of them and do keep calm and the bottom part of it is RF coordinate. So
Yeah, I'd buy one.
there we go.
I'd buy several.
There we go. That maybe that should be the handout for our donation.
There you go. Well, for the
There you
bigger
go.
donations.
Yeah,
Plus a bottle of whatever perfume you
Blue
want.
Spritz. Yeah. Yeah.
Exactly.
WD-40.
Exactly. Well,
The men's cologne.
I can dig it. Well, thank you very much for coming,
Thank you for having us.
and we'll all see you later. Bye-bye.
Bye.
Bye.
How do I get out of this thing? Well,
0.
bye. And I'm almost out of it. I could do a lot of things, but turning off a webinar doesn't seem to be one of them. Maybe this X button is what I need. Bye.